All right, I've got my mic working. Hello, and we're going to do some absolute value. Let's get to it. So first I want to say these are higher level lessons. We want to, our goal is to go from this equation to the graph quickly without needing the table, okay? But just to remind you, this is what it looks, this is why you get, so when you input -3, you get out +3. When you input +3, oh, my finger's big, you get out +3. That's where you get this like bounce back, okay, that a lot of kids call a V. Be very careful because it is different from a quadratic, and your teachers know the difference. By the end of this, we are going to be able to link these graphs to these equations site-wise and just say, that's this, 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 this. Okay, that's the point of today. So let's remind ourselves in my amazing handwriting, and I have it written down again, that y that is essentially, the equation setup is there are these different elements, okay? So you see the absolute value bars with the x, and y and function are the same. Here are the absolute value bars, right? And then we have x in there, and that's the absolute value, okay? That's what those letters mean. We're interpreting. This is symbology. Math is a language. So the y and the x with the bars, that's what lets you know this is absolute value, okay? Now, the a is the same as the slope, and we'll get to that. The h and the k give us a point of the vertex, which is this point right here, right? It's the point of the intersection of the V. So let's just look at my worksheet here, okay? So I have 5 different things we're going to graph. So first of all, we have, you can see it up, and I'll zoom in with, this is the old school zoom. You have, here's the equation, y equals a, x minus h plus k, the slope is a, and there's the vertex. So here's the basic graph. We want to be able to graph these quickly, okay? Here's the basic graph. So we have a slope of 1, and when there's no hk, that means 0, 0. Nothing is 0, okay? So here is 0, 0, the origin, and the slope is 1, so we're going up 1 over 1, up 2 over 2, right? And then it bounces back to the negatives, right? And that's how you get this V, okay? We have arrows at the end. Don't forget your arrows, kids. Okay, so that's this first one. So now we want to know what happens if we have this is the same and you add 1. Okay, so that's then, so if we look back up here interpreting, okay, there's no h. It's still 0, so that means it's not going to move in the horizontal. This is h is horizontal. Horizontal. And the k is the vertical, okay? So that means this goes up 1. So this second graph, the vertex is here. Everything else is the same. And yes, these are going to look like parallel lines because they are parallel, because they have the same slope. Okay, now we get to here, this third one. Well, there's nothing on the outside. That means k is 0. That means it doesn't move vertically. But what's happening here? We say plus 1. So does this mean that our vertex moves right there to the plus 1 in the x? And the answer is no, because when you look at our form that kids call the formula, this is the form. It's not a formula. It doesn't mean you automatically get the answers the way kids seem to define formula. This is the form. The form is minus. So actually this number moves in the opposite direction of what you see. So if this is plus, that means the vertex is going to move in the minus, in the negative. So it's going to be over here. It still has a slope of 1. If nothing's written, that's a 1. Okay, these are the absolute value signs. So now the vertex is over here. And again, the slope is 1. This is actually going to go right through the heart of that other one. Okay? But now let's look at these. 2x. So these are going to look, this is like this, right? There's no hk for either of these. So my vertex is not going to move from my original graph. I wonder if I have a different color. I don't. But what this means is that the slope is 2. So instead of going, here's our original one, right? This is the original graph. Instead of going up 1 over 1, Instead of going up 1 over 1, we go up 2 over 1, up 2 over 1, and the bounce back. I know I'm getting these all in the same graph, and normally I would have different colors, and so I'm sorry. I have all the different colors of dry erase, but not of this. Zoinks back up. All right, last one, and then we'll get to this picture. Negative. Well, what does that mean? So you'll notice there's still no H and K. The vertex didn't move. So the vertex is still here. But this negative means that the whole thing flips over and it goes down like this. That's this graph. Again, 1 over 1, 1 over 1. You're like, Thompson, you're moving too fast. Let's get back to it. I know I moved quickly, and I'm sorry I didn't have other colors, but let's get to this picture. Okay, here we have 4 graphs, and we have 4 equations. We have 4 graphs. Oh, there I go. And 4 equations. Okay. So let's look at this one first. Don't look at the graph A, B, C, D on the side here, okay? Because these are whatever order they need to be. All those over there. Okay, let's look at these and then link them. So h of x, meaning that's the function, is equal to x minus 7 plus 5. Where should that vertex be? Minus 7 plus 5. Where should that vertex be? So the x-coordinate is the opposite of what it presents. So that would be plus 7. And the k is the same, plus 5. Which of these pictures satisfies that? Let's just look again. Negative 7 plus 5. So that means it's going to be positive 7, positive 5. Well, what do you know? It's right there. There's the 5. So actually, this first graph, this first equation, there we go, is graph D. The second equation, plus 5 plus, what is that? I can't see it. 3. Sorry, that's my computer, my phone. So the 8, it presents as a positive, which means given the form is negative, it's the opposite, so it's negative 8. When you go over to negative 8 in the x direction, you can immediately see that there's only one that is at a negative 8, and that's C, graph C. So this second equation is graph C. I should draw on this. Now, the third equation down, f of x, plus 7 minus 5. So again, the 7 is the reverse. It's going to be minus 7 minus 5. And look, it's our first time with a different slope. Look, it's negative. So that means the v is upside down. So negative 7, negative 5, right over here, upside down. So f of x is actually the graph of A, which you can process of elimination this and say that p of x, this last one down there, right, is this graph. Or you can analyze it and, of course, say negative 8 means positive 8, negative 3 is negative 3. So positive 8, negative 3, upside down. Boom. There it is. The point of this lesson is to swap these things out quickly. Okay, you want to be able to interpret the graph quickly. How does it shift? Does it shift up and down, side to side, right, horizontally? Does it flip over? Is it narrower or wider? I am about to tell you something that I am not getting paid a dime for. If you've watched this so far, great. Desmos.com. What I wouldn't have given for Desmos when I was in school. Look at this. Desmos.com. Open graphing calculator. This is incredible. I really wish this existed. Now, you pull up the keyboard at the bottom. There it all is. And you can find absolute value. Hold on, let's find where it is. I have y equals, and I go right down, and there's the absolute value bar. And you see what it does for me? X. And look what it graphed. And then I can go x minus 4, and look what it did. Now we're at 4. Desmos.com is the greatest thing to help you with absolute value, quadratics, linear functions, sine functions. It gives you immediate feedback, like a video game, of what's going on. Could not recommend more.